Guys, and welcome back to another video. So I just want to thank you guys for help bring me back out to make videos again, because since I've been married, I got married on October 2020, so that's actually 2 months ago, and I haven't actually published any videos since up until today. And well, I've just been busy being married and trying to organize a few things in my life. So yeah, but anyways, firstly, thank you guys for returning to watch my videos again. And the reason why I'm posting the November 2020, because it's my first time posting November papers, is because there was no summer 2020 papers. And like, you never know, maybe I might start posting more papers like these, especially the October November series. But yeah, as always, guys, to break it down, we're gonna do a complete walkthrough, and we're gonna go through every single question step by step. Okay. Typically, the paper is 2 hours, but I'm gonna try and aim to finish it in an hour and a bit. So we'll see how it goes. But anyways, without further ado, guys, let's jump straight in. Now, as always, you're given specific formulas into your exam. You got the arithmetic series, the quadratic equation, area trapezium. Now, these are all necessary formulas. I mean, personally, it's better you memorize majority of them. Okay, maybe not arithmetic series, but quadratic, yes. Area trapezium is good to have an understanding of it. Trigonometry is very important. And the volumes not so much, but I'll say to understand volume of a prism, because that's quite a tricky one, and probably how the curved surface area of a cone works. But other than that, most of these are okay. So let's go straight to number one. So there's 25 questions, oof, quite a bit, and we've got right answers in spaces provided. You must write down all the stages in your working. Cool. So let's start, guys. Number one. So the numbers from 1 to 14 are shown in the Venn diagram. Okay, so you got all the values listed in here. So all of these numbers are known as members of the Venn diagram. So everything within A and B is here, but everything outside A and B is over here. And there's 5 elements outside. Now list the members of the set A that connects with B, that intersects with B. So the ones that have in common. Well, that's the middle set. The ones in common A and B are 2, 4, 6, and 12. So we just write here 2, 4, 6, 12. Okay. Now list the members of the set B, and there's a little apostrophe sign. This means the complement B, or everything outside the B circle. Well, looking at the B circle, this is everything that's inside it. You've got 1, 2, 3, 4, 6, 12. So everything outside it includes 8, 14, 10, and then the ones over here too. Okay, so that's all the ones you have to list. Now it's kind of long to list, so I'm just going to list it outside over here. Yeah? So we're going to have, so in order, it's always good to write in order, by the way. So let's start with 5, 7, 8, 9, 10, 10, 10. Let me just cross them out. 11. What's after 11? 13 and 14. Okay. Now next one. Now a number is picked at random from the numbers in the Venn diagram. Cool. Find the probability that this number is in set A but not in set B. Okay, so what we have to do here, guys, is literally go back to our Venn and just look at the elements that's in circle A, in set A, but exclude those that have B elements intertwined with it or intersecting with it. So in other words, we just need the ones that are strictly A, so 8, 14, and 10. So you can see that there's actually 3 elements. Now, because the probability is always out of something, right? In this case, it's always going to be a number picked at random. So a number picked at any possible number from the Venn diagram. Well, in the Venn diagram, we have 14 possibilities. We know there's 14 because we can count them up, or it just tells us here, numbers from 1 to 14. So therefore, the probability is going to be 3 out of 14 chance to pick any element that is strictly A, with no B interference or outside interference. And yeah, guys, that's it. That's one done. So let's move to 2. Now, 2. Toy cars are made in a factory. Cool. The toy cars are made for 15 hours each day, and 5 toy cars are made every 12 seconds. Ooh, that's quite fast, I'm not gonna lie. For the toy cars made every day, the probability of a toy car being faulty is 0.002. Okay, so we're gonna keep a note of this, yeah? Work on estimate for the number of faulty cars that are made each day. Okay, so we're gonna be quite specific here, yeah? For toy cars made each day, the probability of a toy car being faulty is 0.002. So you can say here, probability of making a toy car is 0.002, and you're making 5 cars every 12 seconds, okay? So it's going to be 5 times this value for faultiness, yeah? And how many cars are we making each day? the toy cars are made for 15 hours each day. So let's firstly work out how many toy cars are made, and then we can easily work this out, yeah? So far, you got 5 toy cars every 12 seconds. We're going to work out how many seconds are there in 15 hours. Well, we should know that 1 hour is equivalent to 60 minutes, or 60 times 60 seconds. Okay, and that gives us 3,600. Now we can divide this quantity by 12. So 3,600 divided by 12. This gives us 300. So let's write here. So 3,600 divided by 12 gives us 300. So this means 300 multiplied by 5 toy cars will give us how many cars are made in a day. So therefore, there are 300 times 5, which is 1,500 cars made each hour. So not daily, sorry, each hour. Okay, and because we know that there are toy cars made for 15 hours each day, so this means we're going to multiply this answer by 15. So that's another step. So therefore, 1,500 cars times 15 hours, that's going to give us 22,500 cars. Okay, so now we're pretty much ended this, and we know that the probability of getting a faulty car is 0.002. So therefore, just multiply these number of cars by the faulty rate. So that means now 22,500 times your faulty rate, and this is going to give us 45 cars. Okay, so that's not bad at all. But yeah, guys, that's the end of number 2. So let's move on to the next one. So on the grid, draw the graph of y equals 7 minus 4x for the values of x from minus 2 to 3. Okay, easy way to do this. You literally just plug in the values for x into this equation, like just 2 values. I usually pick the endpoints, like what they give us. So what I would say, you can say let x equal minus 2, and now plug into this original equation. You can have y equals 7 minus 4. Instead of x, it would be times minus 2. When you replace a letter with a number, always wrap in a nice bracket, okay? And then let the calculator do the work. So it'll be 7 minus 4, bracket minus 2, and you should get an answer of 15. What is this telling us? When x is minus 2, y is 15. So let's write a coordinate here. We have a coordinate of minus 2 and 15. And remember, guys, it's always x, then y. So you always run before you jump, okay? Now you got one of the coordinates, minus 2, 15, so I'll just quickly plot it here. So minus 2 all the way up to 15. So 15 will be between here, so here it is, minus 2, 15. Now all we need is another point, so I'm going to pick the end of endpoint 3. So we can say on this, let's write on the right, let x equal 3, therefore y equals, and again, copy the equation, replace x with 3. So you can get 7 minus 4 bracket 3. Now once again, let your calculator do the work, guys, yeah? Seriously, because you're using a calculator, always just let it do the work. You don't need to work things out. And here you should get minus 5. Now this indicates that we have a y coordinate of minus 5 when x is 3. So our coordinate here is 3 first, then minus 5. And again, just plot in. So 3 along the x-axis is at the end here, and you're going to go 5 down, so minus to minus 5. So it'll be here. And you're pretty much done. Now I'm going to try and pinch this out here so you can see the full screen. Okay, alright, cool. Come on. Yeah, so the whole point is, guys, you need to draw a straight line. So I'm not going to lie, it's kind of hard to draw a straight line on the computer. So I'm just going to do a dotted line, yeah? Because for me to draw a straight line, I need to use a different app, and I haven't got it running right now. So that's what it's going to look like. Just always use a ruler, guys, yeah? So use a ruler. Now here is a list of 6 numbers written in the order size. Okay, so remember, when they use repeated letters like y, this means these are the same values, yeah? And because they're written in size, we can see that the x value is between 7 and 10, and y is bigger than 10, okay? Now the numbers have a median of 9. Well, the median means it's the middle value of the set of data. So the median is always bang in the middle. So this means that between x and 10, there is a 9. So the halfway value between x and 10 is 9, so this x value must be an 8, because between 8 and 10 you have 9, okay? Now, okay, cool, so x is done. And the numbers have a mean value of 11, okay? Now, what this is trying to say is that if you added up all these numbers and divided by how many numbers there are, which is 6, you should get a total of 11. In other words, let's just add this up, because this means, well, if you add them up, you should have a total of 66, because 66 divided by 6 is 11. So adding up these digits, 4 plus 7 plus x plus 10 plus, and you got 2y, so it'll be 2y. We're now going to have, or tidying up, 4 plus 7 is 11, plus 10 is 21, plus x, which is actually an 8, which I forgot to write down, plus 2y. And again, tidying up, 21 plus 8 is 29, plus 2y. And we know all of this is supposed to equal 66, because if you divide them both by 6, you'll get 11. Now, yeah, so now we just have to solve this, solve for y. So this is now literally an equation to solve. Well, to do this, you have to rearrange to make y the subject. When I say y the subject, I mean you need to get y equals something, yep? Just leave y isolated. Now to do that, we need to firstly move 29 to the other side. We've got to subtract it. So 66 take away 29 gives us 37. So now we're left with 2y here equaling to 37. Now halving that value, we're now going to get exactly, well, according to the calculator, a value of 18.5. And yeah, guys, this should be our result. Hopefully, I mean. Okay, so let's move on anyway. Now, number 5. So write 5.7 times 10 to the negative 3 as an ordinary number. Okay, all this is telling you, you got power minus 3. This means you need to have 3 zeros behind the 5. So we look like this, 0, 0, 0, and then 5, 7. And now, because you want an ordinary number, you got to put the decimal place always here. So that's the form they want. And that goes right there. Now, write 800,000 standard form. Same thing applies. You firstly just look at the first digit, and then you count how many numbers are after it. Well, you got exactly 5 values. So it'll be 8 times 10 to the power 5. And this is standard form, guys. It's always times 10 to the power something. 5 digits in front means a positive 5. If it was written, if it was 0.0008, well, 5 digits before the 8, it'll be a negative 5. And yeah, that part's done. Now, work out this entire equation here. Thankfully, this is easy, guys. You just have to put this in your calculator. Now, word of advice: if you're gonna write this in your calculator, always use the fraction button, yeah, and then insert the values. Put all of this in the top line, and then put all of this in the bottom line. And it's important you do it all at once. So I'm going ahead and do it right now, yeah. So you got 3 times 10 to the power 5 minus 2.7 times 10 to the power positive 4 over 6 times 10 to the power negative 2. And according to my calculator, I got a result of 455 and 4 zeros. So that's actually, if you put comma every 3 digits, that's 4,550,000. It doesn't tell you to put in standard form or anything, so you can actually leave it like that, okay, and you're good. So let's move on anyway. 6. Now, a rocket traveled 100 kilometers at an average speed of 28,440 kilometers per hour. Okay, so this sounds like a speed question. Now, for speed questions, it's always speed equals distance over time. This is the formula we've got to memorize here. Speed equals distance over time. Now, work out how long it took the rocket to travel the 100 kilometers. Give your answer in seconds. Oh, cool. So it doesn't seem too bad. I think first things first, if you're going to work out, so they're looking to find the time here. Now, according to this formula, this is speed equals distance over time. To find time, you've got to make t the subject. So if we multiply t across and divide s, in other words, trade places, you're going to have time equals distance over speed. Literally multiply t and divide s. Now let's replace our values what we know. So we had 100 kilometers, which is the distance on the top, speed at the bottom. So we can say that the time equals a distance of 100 over a speed of 28,440. Now again, putting this in your calculator, guys, you should get a value of, I'm doing it now, well, you're going to get a fraction, you're going to get a decimal value, which is roughly 0.0035516 ... And this is all in hours, yeah? Reason why is because the speed unit was measured in hours. Now to go from hours to second, just like the previous question, we multiply 60, right, to get minutes, and to multiply 60 again to turn into seconds. Because we know there's 60 minutes in an hour and another 60 seconds in a minute, so 60 times 60. So therefore our actual result is going to be what we had earlier but we're going to multiply our answer in our calculator by 60 and another 60. Now if you do that, guys, you should get a final result of, well, you're going to get a fraction, 1000 over 79, or 12.6, oh my god, 12.658 seconds. Now just to be clear, they want us to round our answer to the nearest second, so that means you want whole numbers. So you can look at 12.6, 6 is big, so you can round up to 13 seconds. And yeah, guys, that's really it. So that's quite fast. It takes 13 seconds basically for a rocket to travel 100 kilometers. That is mad quick. That is really quick. But yeah, cool. Now, number 7. So, part A. Solve 5 times 4 minus x equals 7 minus 3x. Show clear algebraic working. Okay, this is algebra. Everyone loves algebra questions. Now, to solve these kind of problems, you must always expand the brackets. And to expand it, you multiply the inside by the number outside, which is 5. So 5 times the inside will give us 20 minus 5x. And you're going to equate it to the right hand side automatically. Yep. Now, once again, we're going to try and make x a subject here. So what I'm going to do, I'm going to move negative 3x across and positive 20 to the right. So to move it across, you need to add 3x and subtract 20. If I add 3x, minus 5x plus 3x is minus 2x. And then 7 minus 20 is minus 13. And lastly, to get x a subject, we need to divide minus 2 across. So x is going to equal minus 13 over minus 2. And in your calculator, guys, 13 divided by 2 is going to give us, minus 13 over minus 2 is going to give us 6.5. Cool, and that's your answer. For B, which is, okay, you got quite a few algebra questions there, which is nice. So for B, factorize fully 16m cubed g cubed plus 24m squared g power 5. Okay, that's kind of a mouthful there. Now, to factorize something, factorize just means whip it up in a bracket or take out the common factor in both terms more accurately. Yeah? Now, to do that, guys, we look at the numbers first and we ask ourselves, what's the highest times table they're both in? Well, 16 and 24 are in the 2s, 4s, they're also in the 8 times table, and that's the highest. So first things first, we know we can divide them by 8, so we whip out 8 outside. We look at the letters now. Well, according to both of them, one's m to power 3, one's m to power 2. We pick the highest possible they both go into. Well, they both have at least an m squared. They both have 2 powers of m. This has an extra power. So we can whip out 2 powers of m outside. And for g, they both have at least 3 powers of g. G to the power 5 has an additional 2. So we can take g to the power 3 outside. Now what this means is that we just fill out what's inside. So this now has to become a new term, plus this term has to become another new term. Well, inside the bracket, because we took our 8m squared g cubed, we just divide it now. So dividing this by 8m squared g cubed, 16 over 8 is 2. M to the power 3 divided by m squared, well, taking up 2 powers of m gives us a single m power, and taking out all 3 powers of g makes it disappear, so there's nothing there. For the second term, 24 divided by 8 is 3. We took out all powers of m, so 2 squared powers, so that's gone. For g to the power 3, we took out 3 powers of g, so we left with 2 powers of g, so g squared. And that's it, guys. And this question is done too. Now for C, it's kind of the same thing. Actually, no, it's not. It's quadratics. So factorize y squared minus 2y, take away 48. So for this kind of problem, this is a double bracket problem. Every time you got something squared, plus or minus another thing, plus or minus a number, you always think double brackets. Yeah, this is like a must. Now to solve this, all you got to do is ask yourself, what two things multiply to make y squared? Well, it's y times y. That's always the default. And now we ask ourselves again, what two numbers multiply to make 48? So let's list that up here. You got 1 and 48. You got 2 and 24. You got 3 and 16, I believe. So 3 times 16. Yep. And what else? You got let me see, 4 times 12. Anything in between? 6 and 8. Yep, 6 and 8. Now, out of this set of numbers, you got one of these pair has to go in. And to work out the right pair, we need to figure out the one that has the difference or sum of 2. Well, the only thing that has a difference of 2 is 6 and 8. That's the only clear one. So 6 and 8. Now we ask ourselves, how do you get minus 2? Well, to get minus 2, it would have to be negative 8 plus 6, because negative 8 plus 6 is us negative 2. And that's it, guys. This is done, fully factorized. Now part 2 is a follow-up. Hence, solve y squared minus 2y minus 4y equal to 0. In other words, solve what you just did and equate to 0. So we're going to copy what we just did, and we're going to now equate this to 0. Okay, so y plus 6, da da da. So to solve this one, this is straightforward. You literally just change the signs. So if it's y plus 6 equals 0, that means flipping the sign, y equals negative 6. And if y minus a equals 0, well, this means y equals plus a. And yeah, these two questions are done as well. Whew, I'm not gonna lie, we're flying through these questions really quick. Yeah, this is really good. So number 8. Now here is a 10-sided polygon. Okay, so you got 10-sided, you got everything done. The only weird one is that x is in the outside, which I don't know why they did that. It's just making it kind of confusing. So what we're gonna do, if they use x outside, we're gonna put y inside, yeah. So it's gonna look a bit like that. Now, what they want? So work out the value of x. Cool. Alright, so for any single polygon, guys, always remember these set formulas. Oh yeah, but I forgot to reference. I want to thank also this what is it? GCSE IGCSE files Telegram channel, because these guys pretty much support me with the video, and I want to thank these guys a lot. I also want to thank a few other subscribers who actually sent me an email requesting this paper and also give me some access to it, because I don't always have access to papers, guys. You know, I don't actually work in the school industry at the moment. I've moved to a different industry, which is I work at university. But yeah, currently I work at university. But again, I just want to thank these guys. So thank you guys, and I appreciate, because you guys are helping out a lot of people outside as well. And there's a lot of people in different countries in your country that probably needs revision, and everyone's working at home. So this is going to be quite helpful for everyone, including yourselves. And yeah, I'm glad. So let's get back to the question now. So we got a 10-sided polygon, yeah? We just need to know a couple formulas for polygons. The first things first, we need to know that the interior angles, I plus the exterior equals 180. Just to know what interior angle is, if this is like a shape, if this is the inside of the shape, like for example, I don't know, like a pentagon, this is the interior angle, and the straight line outside makes it the exterior. So for this kind of shape, if I just do the straight line across, 140 is interior, this must be the exterior. So these two must add up to make 180. Now that's just one of the forms. The other forms you need to know is that the sum of all interior angles, so the sum of all interior angles, S, equals the number sides minus 2 of a shape times 180. Okay, this is going to sound kind of weird, but that's what the formula tells us, yeah? This is trying to tell us, for example, if we have a 10-sided shape, which is n, so n equals 10, we're now going to have the sum of all of this to be n take away 2, 10 take away 2, which is 8, times 180, and that'll give us how much these angles are supposed to add up to. So let's work out, guys. 8 times 180, that's going to give us 1,440 degrees. So we know immediately that all these values add up to 1,440 degrees. I'm not going to lie, this is kind of long to add up now, yeah? Because I haven't got the masking open. So let's add up these values quick time, yeah? So 125 plus 134 plus 168 plus 150, 148, 150 again, 168, 134, 125. Okay, so I just added up all these numbers, yeah, and I got 1,302 degrees. Okay, and now I'm going to add y to it as well, and that's supposed to equal 1,440 degrees. So this means if I subtract, if I solve for y, if I subtract 1,302 across, I should get 138 degrees. Now that's the interior angle, right? On the outside, we want to get x. So another thing you need to know, guys, is that all angles around a point adds up to 360, yeah? So x and y make 360. That means 360 take away, I'll write down, 138 degrees. It's going to give us answer. So 360 take away that will give us 222 degrees. Cool. That's it. And that's your x done, guys. That's your x done. And what's that worth? Please don't say it's worth 2 marks. 4 marks. Alright, cool. Not too bad. Now, next one. So, okay. So far, the paper hasn't been too bad. The first 8 questions have been pretty alright. I think it's going to get a bit harder, probably from number 10 onwards. But we don't believe in hard. We can do this. Now, number 9. In a sale, normal prices are reduced by 20%. Okay, so for these kind of questions, I already know what they're asking. You should always have the original value, and it's always multiplied by some multiply. So 1 plus or minus a rate, and it gives us a new value. Okay, OV is the original value, in other words, the normal price. NV is the new value, which is in this case going to be the sale. Okay, so I'm going to read the rest of the question. Now, normal price are reduced by 20%, so this means that it's going to be 1 minus the rate, so 1 minus 20%. That's 1 minus 0.20 or 2, which is 0.8 or 80. So that's our new rate. A bag costs 1,080 rupees in the sale. Work out the normal price of the bag. Okay, so we know that the new value was 1,080 rupees. They want us to find the OV. So this means if I update the formula, we have OV, that'll be, instead of 1 take away 20%, that gives us 0.8, and that's going to equal 1,080. Well, to get the normal price, just make OV the subject. So divide 0.8 across, you get 1,080 over 0.8. And that's it, guys. This is your answer. So 1,080 divided by 0.8, you get, that means the original price was 1,350 rupees. Not too bad. A bit pricey, I'm not going to lie, but decent. So 3 marks for that. These questions are all just quite short, I think. So, number 10. Oof, that's some massive powers though, I'm not gonna lie. Okay, so you got A equals 2 times 3 to the power 43. B equals 16 times 3 to the power 37. So they actually did not, 16 is not in prime numbers, so I think that's what they want you to do, is to always make them to prime. And A, find the highest common factor of A and B. Before we even do that, we need to firstly fix up B, yeah? So we need to know what 16 is. 16 can be broken down into 2 and 8, so always use the factor tree. 8 can be broken down into 2 and 4. 4 can be broken down to 2 and 2. Oh, I should have guessed that. 16 is the same as, guys, how many 2's are there? It's 4. It's 2 to the power 4. So essentially, B is just 2 to the power 4 times 3 to the power 37. Cool. Now, to find the highest common factor, you just see what they both, the highest power they both have in common is. Well, if you look at A, so this is 2 to the power 1. For the 2 section, they both have at least a single power 2, so the HCF would be 2 to the power 1. For both the 3s, the highest power they both have in common is 37 of each, so 3 to the power 37. And yeah, I think that's all you can do. That would be your answer. Now, what's next? B. Express the number A times B as a product powers of its prime factors. Give your answer in simplest form. Ooh, interesting question. So A times B. So they want us to just combine these two terms, yeah? So it'll be, for example, 2 to the power 1 times 2 to the power 4, and 3 to the power 43 times the other big power. That's actually quite easy. I'm going to do it right here, guys, yeah? So A times B is going to equal, well, 2 to the power 1 times 2 to the power 4. You just add the powers. That's 2 to the power 5. And then next one, for the 3's, it will be 43 plus 37, that's 80. And yeah, we're done. That's done for that question too. How is that 2 marks and how is this one 1 mark? And this one I think is always a bit more trickier. Anyway, let's move on. So 11. The diagram shows the trapezium ABCD in which BC and AD are parallel. So I remember we looked at the formula recently. Let's see if we need it. The trapezium has exactly 1 line of symmetry. That's going to be perfectly in the middle. The length of BC and AD are given. The trapezium has an area of 179.4 centimeters squared. That's good to know. Let's put that over here. Area. Work out the size of angle ABC. ABC. Ooh, interesting question. So they want to find this angle here. Okay, cool. Give your answer correct to 1 decimal place. Right. So to find that angle, okay, interesting. So what first thing you want to do? They gave us the area of a trapezium. Now, if they give you an area of something, use that formula and try and work out what was missing. Well, in the formula sheet, the area of a trapezium was A plus B over 2 times a vertical height. This vertical height is the dotted line we just did, yeah? Now we know what A plus B are. These are the 2 parallel lengths. So A could be 8.4 and B could be 17.6. Let's write it down, yeah? So the area, but this A is the area, not this point A. So I'm going to rewrite as area now, yeah? The area is going to be 8.4 plus 17.6 over 2. So write that down, 8.4 plus 17.6. That gives us 26 over 2 times the height. Oh yeah, and the area, we know what the area was. The area was 179.4. Okay, 26 divided by 2 is 13. So we're going to have 13h on the right side. So to get h, divide your answer by 13. So h is going to be 179.4 divided by 13. And that will give us, guys, let's work it out. It will give us exactly 13.8 centimeters. So this means that the height, the vertical height is 13.8. Now, let's go back to the question, right? The question wants us to work out angle ABC. So the trick is now is to actually think of this one as some sort of triangle problem, yeah? So let's just look at it this way. If I drew a dotted line down here, we know that the vertical height is the same everywhere, right? So this height is also 13.8. The easy thing now is that we pretty much are dealing with, what's it called, a right angle triangle, okay? We know that the length from here all the way to here is 8.4, but we know that the whole thing is 17.6. So let's go find the remaining lengths, yeah? We know that these two lengths are equal. We know they're equal because it says that the trapezium has one line of symmetry. That means it's bang in the middle. It must be symmetrical on both sides. So these two lengths, let's call them x, are the same. Okay? So let's write it down. So first things first, let's subtract 17.6 away from 8.4. So if you did that, you should get a difference of 9.2 centimeters. This means that these two x's equal 9.2. So if you half it, that means each of these x lengths are 4.6. So let's update this. This is 4.6 and this length is 4.6. Now the trick is, guys, if you work out this angle here, and you can just add it to 90 degrees to get the whole length across, because this is 90, we know that. I should just write a square. I don't know why I did that. This is 90 and this could be, I don't know, let's call it y, yeah? So let's just redraw this right now. So right angle triangle, you got y, you got 4.6, and you got 13.8. Okay, and this is right angled. Now to use SOHCAHTOA, so that's it. When you guys got trigonometry, when you got right angle triangles, you either think two things: Pythagoras or SOHCAHTOA. So I'll write down SOHCAHTOA. To use SOHCAHTOA, we just need to know what are the names of these two lengths. Well, any angle opposite the angle of interest, opposite y, which in this case 4.6, is known as the opposite, literally. So this is the O, opposite. And the one next to it, the other length, is the adjacent. Adjacent means next to the angle. The long diagonal side, guys, is always the hypotenuse, but we don't need the hypotenuse. So we're going to pick anything that has an O and an A. Well, we can't use SO, we can't use CA, we can use TOA, because that's O and A. And T stands for tan. So to write this TOA out, TOA stands for tan of the angle, so tan of y is going to equal O opposite over adjacent, so O over A. O, which is 4.6, A, which is 13.8. And that's it, guys. Now to find the angle y, all you got to do is find, is basically tan inverse this, get tan to the other side. To do it, you need to tan inverse. So make sure you use that in the calculator. Okay, so that's it. So when you put that in, let's see what we get. So tan inverse of that value, 4.6 over 13.8. This is going to give us an angle of 18.4 degrees. Cool. But that's not the final answer, yeah? That's the angle of y. We want the whole of ABC, so it'll be y plus that right angle 90 degrees. So y, so that plus an additional 90 should give us 108.43 degrees. But how many decimals do they want it? Give to 1 dp, yeah? So that means it'll just be 108.4 degrees. And that's it, guys. That's this question done too. So solve the simultaneous equations. 7x minus 2y equals 34 and 3x plus 5y equals minus 3. Okay. So these kind of forms are just known as linear pairs, right? They're linear because there's no x squared terms, there's nothing funky about it. And it's all arranged in terms of x and y's. So let's try and do this linear pair. Now, the easiest way to do this, guys, is to pretty much make the coefficient of x, well, the numbers in front of the x, the same. You could do y, but I prefer x because it feels more natural. Now to do that, we've got 7x and 3x. The easy way is to multiply both these terms by the opposite pairs. So you got 7x and you got 3x. You know they both can go into 21. So let's multiply the top row by 3 because it's a 3x and multiply the bottom row by 7. And if you do that, they both become 21x. So let's do it. If you multiply the first row by 3, you get 21x minus 6y equals, now 34 times 3, you get 102. For the bottom row, the same thing applies. You're going to get 21x. 5 times 7 is 35. And then you got y. Minus 3 times 7 is minus 21. Okay, so far so good. And because you got both values of x the same, the trick is to now subtract these pair of equations. Because if you subtract them, the x will disappear and you're left with an equation in terms of y. And that makes it easy to solve. So subtracting all of this across, I put these two in a big minus outside. 21x become nothing. Minus 6y minus 35y gives us minus 41y. 102 minus minus 21, so you end up adding these two numbers. You're going to get 123. So that's good. And to make y the subject, guys, just divide minus 41 across. So y would end up becoming 123 over minus 41, which is minus 3, I think. Divide by minus 41. Yes, minus 3. Okay, cool. So for simultaneous equation, guys, there's not just y to find. There's also x to find, yeah? So now you found y, let's find x. Well, we don't have to repeat everything. All we have to do is pick an equation that looks the simplest. I think the simplest looking equation is the very first one, the very first line. And all you got to do is replace the y with what you found. So let's copy the first equation again. So 7x minus 2. And instead of y, we're going to whip in a bracket and write minus 3 equals 34. Alright, cool. Almost done. Now, expanding this out, you got 7x. Well, you got minus 2 times minus 3. That's a positive 6, or plus 6. And that equals 34. Now, solving this equation, we've got to subtract 6 across. So it'll be 7x equals 34 take away 6, which is 28. And now to get x, you just got to divide it by 7. So 28 divided by 7 is 4. And we're done, guys. We now have an x value of 4 and a y value of minus 3. So we just make it clear. I think you can write the bottom as well, so that's cool. So next question again, 13. So Jan, this is a personal name. So Jan invests $8,000 in a savings account. The account pays compound interest at a rate of X% per year. Okay, so just like the previous percentage question, you have an original value, you have a rate, because it's increasing, it'll be a positive rate and equals a new value. The only difference now is because you're dealing with years. So we're going to add a little year component. So let's put a little power here. Let's call this time, yeah? So how many years are involved? Now, okay, so it pays 8% per year. So that the rate is X. And the original value is $8,000. At the end of 6 years, there is a total of this much money in the account. So that's the new value. Work out value X. Okay, cool. So let's go ahead and update it. So we know the original value is 8,000. So I'm going to copy the formula, guys. We know it's increasing by X% per year. So that's going to be 1 plus X%. Okay. And it's going to be over 6 years. Great. And it's now going to equal $8,877.62. And well, to find the value X, guys, you just got to rearrange this and make X subject. So let's try out. So first things first, I would divide 8,000 across, guys, yeah? Because that's going to simplify the equation. If you do that, you just left with the bracket. So 1 plus X% to the power 6. This value, 8,877.62 over 8,000 gives us roughly 1.1097025. It's better you write all the digits for now. And next thing you want to do is pretty much get rid of the 6th power. To do it, you need to find the 6th root. So in your calculator, you could use the cube root button, so it looks a bit like that. And then just delete the 3 and put a 6. So you want to find the 6th root of this value. So this means you're now going to have 1 plus X%. The 6th root of that is going to give us, I'm going to do it right now, you're going to get 1.01, 1.0, what's the point? 1.0175. And you're going to get loads of zeros and then 2, 2. So 3 zeros and 2, 2. Again, so next we're going to subtract 1 across, so you're left with X%. That's going to equal, well, subtract this by 1, you're going to get 0.0175. I think we can ignore the rest now, because they only want 2 decimal places. And, oops, scroll down a bit. And well, just remember, x% means x over 100, yeah? That's what it means. Percent means per 100 in French. And again, copy the right side. So all you want to do, guys, is just multiply this value by 100, and then you get x value. So times this by 100, guys, you're going to end up getting 1.75%. And that's your x value. So just write 1.75 actually. Yeah, cool. And we're done, guys. That's number 13 done. So 14. Alright, so f is inversely proportional to the square of v. Okay, so you got this keyword proportional. Proportional symbol looks like that, yeah? And it's always the same as saying equals some scale factor k. Now with a statement like this, f is inversely proportional to the square of v. This means that f is proportional to the square of v. Because we've got inverse proportional, it means 1 over. The square of v means v squared. So here's our equation. Now we're going to replace this proportionality symbol with equals k. We now have f equals, so k times 1 over v squared is k over v squared. And this is our equation, guys. So all they want you to do is find a formula for f in terms of v. We pretty much got it. The only problem is that you got k involved, and we need to solve this k using the given that terms. So it says, given that f equals 6.5 when v is 4, so let's write it down. Replace f with 6.5, k over, and replace v with 4, so 4 squared is 16. Find the formula. Well, we know the value k is here. If we multiply, make k the subject, we multiply 16 across, so 6.5 times 16, k will give us 104. This means that now the formula over here updates to f equals 104 over v squared. And that's it, guys. Yeah, this question was quite easy, I think. So next one, 15. Was that it? Yep, 15. So Harry has 2 fair 5-sided spinners. Okay, so fair means all equal. Now looking at both of them, you got 2 reds, meaning the probability getting red would be 2 out of 5. That's red. Probability getting green is 3 out of 5. So I'll just put a circle. For the right side, you got 4 reds actually. So it'll be 4/5 for red and 1/5 for green. Cool. Alright, let's keep going. Harry's going to spin each spinner once. Complete the tree diagram. Cool. Alright, cool. So to get red, we just did it all. So red was 2/5 for spinner A. So it'll be 2/5 and 3/5 for green. For spinner B, we found out that red was 4/5 and green is 1/5. So 4/5, 1/5, and then 4/5, 1/5. It's always going to be the same because no matter what, spinner B always has fixed probabilities and spin A has fixed, no matter which route you go. Okay. What was the question? Work out the probability that at least one of the spinners will land on green. Okay, so probability at least one will land on green. So what it's trying to say here, guys, yeah? You can either get, I don't know, you can either get both, that's not green, you either get both greens, or you either get a green then a red, or you can even get a probability of getting red first and a green second. So that's what it means. Get a green and spinner A, then green spinner B, or green first and red, or red and green. So this is what they want us to work out. So let's go back up there again, yeah? So according to our probability tree, if you want to get 2 greens in a row, it's 3/5 times 1/5. Okay, so that's this one done. 3/5 and then 1/5 second. To get green first and then red second, what that means, you need to get you need to go down this down route, so get green first and then a red second. So 3/5 times 4/5. And lastly, to get red then green, according to the tree, you need to go up the tree, so 2/5 and then 1/5. Okay, so 2/5 and then 1/5. And yeah, now all you go do, guys, is work this out and then add up the total probability. So that'll give you the actual real probability of getting at least 1 green. So 3/5 times 1/5, 3 times 1 is 3, 5 times 5 is 25. 3 times 4 is 12 out of 25, and this is 2 out of 25. Meaning the total probability, the real probability, will be the sum of all of these. So just add them up. Well, 2 plus 3 is 5, plus 12 is 17 over 25. So you got pretty much a high probability. So really high chance of getting a green. And yeah, guys, I think that's the end of this question. So 16 now. Okay, so this is circle geometry. Definitely go concentrate on this one. All right. Okay, cool. So before we look at this, when you guys do a question like circle geometry, always think of what's inside the circle. Well, you can kind of firstly see that there's a four-sided shape here in every single corner inside the circle. Now, when you got a four-sided shape, we have something known as a cyclic or cyclic quadrilateral. Yeah, cyclic quadrilateral. What this means is that the opposite pairs, for example, are M and P, add up to make 180. So if you say M plus P, this equals 180. Likewise, the angle at N, which is 58, plus the angle at L, wherever it is, would equal 180. So another one, N plus L equals 180. Well, immediately, I'm just going to go ahead and fill this up before we solve it. If this is 58, that means 58 plus L equals 180. So that means L equals 180 take away 58. And this could help for your reasoning, guys. It's always good to write these reasonings out. So even though I'm saying in words, try and write what I just said in words into your answer booklet, because that's how you actually get the marks too. You can write cyclic quadrilateral, but we have to say angles on opposite end sum up to 180 of a cyclic quadrilateral. And it's good to write formulas like that. So immediately L here is 122 degrees. Cool. Another property, guys, yeah, you can kind of see like a web form. So between N, M, O, and P, so this is kind of like a spaceship form. So what I always take it, I always rewrite it here, redraw the shape. If we know one angle here, the angle in the center of the circle is always double the angle behind it. So we can see from the shape that O is in front of N. So if N is 58, that means angle O is double 58. So let's write down. So we can say this angle here is going to be double 58. So 58 times 2 equals 116 degrees. If it helps to give it a name, you can say something like this. Angle at N is pretty much MNP or PNM. So angle MNP, P is half of angle MOP, okay? And you can also add in words that the angle in the center of the circle is always twice the angle at the circumference. Angle in the center, twice the circumference. Okay? Yeah. Okay, I think that's said properly. I need to double check it, guys. I'll leave a note afterwards, but yeah. So let's go back to what we're doing. So L, M, N, and P are points in a circle. Angle MNP is 58 degrees. Find the side angle MLP is MLP. So we did it. It's 122. And we gave a reason already previously, yeah? So this is part of a cyclic quadrilaterals and cyclic quadrilateral, and two angles on opposite ends sum up to 180. So just take that off. Find the sides of the reflex angle MOP. No reason given, it seems. Cool. MOP. Okay, so MOP. So what we did, we found MOP, but the reflex part means the one behind it, the one bigger than 180. So this is straightforward. We did our reasoning on the right here. To get the other side, we should know that all angles around the circle add up to 360. So it'd be 360 take away 116. So that's right here. So 360 minus 116, that's going to give us an answer of 244 degrees. And that's your answer for MOP, 244. Easy. It always helps to try and do in advance, guys, these questions. It helps a lot. Now, 17. So a metal block has a mass of 5 kg, correct to the nearest 50 grams. Ooh, sounds like a bound question. The block has a volume of 1.84 times 10 to the negative 3 meters cubed. Correct, freestanding figures. Yep, this is totally different. Work out the upper bound for the density of the block. Give your answers in this form, kg over meter cube. Okay, so first things first, density formula. Okay, so the density formula, guys, I'm going to just call it D for now, yeah? So D equals, and it always helps to look at the units you're working with. It says kg per meter cube. Well, kg is a mass, and meter cube is a volume, so it says over here. So it means mass over volume. Give your answer in mass over volume. So that's our units. Now, to get an upper bound, basically, of this, you need to get pretty much the greatest possible mass, so the upper bound on mass, and the lowest possible volume. What happens when you do that is that you end up getting the greatest possible value. The bigger the gap, the wider the gap, the greater the density. So we need to find the upper bound for mass and the lower bound for volume. Now let's do it. So a metal block has a mass of 5 kg, corrected nearest 50 grams. What I will do, guys, is firstly convert 5 kg into grams, yeah? So we have pretty much 5,000 grams, and when it says nearest 50 grams, what that means is that you want to be either plus or minus 25 of each. So the trick is you always half the nearest whatever value they give you. So the upper bound would be half of 50, which is 25, and the lower bound would be 25 too. So it's always plus minus 25, meaning the upper bound, which is the plus one, would be 5,025 grams. So that's what we want. But they want it in kg, right? So that's the same as 5.025 kg. Cool. Okay, and now for the volume, a nice easy trick is to first you rewrite this into ordinary numbers, yeah? So because you got 10 to the power minus 3, this means you're going to have 3 zeros behind that number, 184. So it'd be 3 zeros and then 184. And as always, standard form and ordinary numbers, always put a decimal point over here, okay? So let's get back to this question now. Now, it says correct to three same figures, so it's being rounded. The trick is to always put some kind of interval behind it, yeah? So I'll always do this, guys. Always put this kind of interval. So we're going to write a form like that, yeah? So it will be less than a number or less than equal. And what we do here, when you want to find the upper bound, so this is the upper bound value and this is the lower bound, all we do is always add a 5 at the end of three same figures. So it'll be 0.00184 and then just add a 5. It's always like that, guys. And to find the lower bound, just subtract this 4 by 1, so it becomes a 3. So it becomes, there's no space here, 0.001835, and that's it. It's always like that. It's always pretty much in that form. So we're done now. Now we have a lower bound value, which is here, and we got upper bound value for grams. For our mass, sorry, which is here. And now we just divide the two values. So therefore, we can say that the upper bound density equals 5.025 over 0.001835. I got roughly, was it? Give you answer to one decimal place here. I got 2738.4. Okay, I think this could be right, but it's always good to check, guys. So please check and confirm this answer is correct. I'm gonna check the mark scheme anyway after, but because I'm posting this the day before the January 2021 exam, the first paper, don't have much time to check properly. So yeah. Anyway, that's cool. Let's move on to the next one, yeah? So 18. The table gives information about the heights in centimeters of some plants. Okay, cool. So you're given some height in centimeters of plants. There's a lot of studies they do, in these kind of questions. So many different kinds of studies. And frequency tells us how many there are. So for example, there are 35 plants that has a height between 10 and 20 centimeters. And there's only 8 plants that have really tall plants between 17 and 80 centimeters. Only 8 of them. Now, okay. On the grid, draw a histogram for this information. Cool. So histogram, what do we need for histogram? They don't give us much, do they? So they give you the height, which is the class width. So histogram need two components here. You need firstly the class width, which is the interval range. So we have that class width. We need the frequency, which we got. We can call it F. And we need one more component, which is the frequency density. So frequency density, FD. So frequency density is pretty much the height of the graph. So let's write here, frequency density. Now to work out the frequency density, you got to think of it as a rectangle. So let's just draw an example shape here, right? If you got a rectangle here, we know that this is the class width and this is the frequency density. The area is the frequency. So for the first one, for example, 10 to 20, that has a width of 10. We know the area, the frequency is 35, so the block equals 35. That means the area of this block, or the height of it, will be 35 divided by 10. Or the area will be 10 times something, gives you 35. Because we're interested in the height, this part, the frequency density, we can say that FD would now equal the frequency divided by class width. So frequency over class width. That's it, guys. That's what we need to calculate. So let's do it right now. Let's work out frequency density. Yeah, all these values so we can actually plot into the histogram. So I'm going to put in bracket next to the class width, next to the height of how wide it is. So between 10 and 20 has a class width of 10. Between 20 and 35 has a class width of 15 because you subtract. 50 take away 35 is 15 again. This one is 20. and the difference between 70 and 80 is 10. Okay. Now for this one, the frequency density for the first column would be frequency over 10. So it would be 35 divided by 10, that's 3.5. Next one, 45 divided by 15 is 3. 75 divided by 15 is 5. 40 divided by 20 is 2. 8 divided by 10 is 0.8. Okay, cool. By the way, these are full stops. I don't know why I do that sometimes. It's not a point, it's a full stop. Now, to put this into perspective, guys, yeah, what it's trying to tell us is that the maximum frequency density will be 5. So on the y-axis, it's going to go up to 5, but we need to balance it properly, yeah? So let's do the counting. So I think every major line is 1. So this was 1, and this was 2, 3, 4, and then just scroll up a bit, 5. Perfect, and it fits nicely, yeah? Now the class widths, yeah? Now we just got to shade them in. So between 10 and 20, it has a height of 3.5, yeah? Between 10 to 20, it has a height of 3.5. 10 to 20, height of 3.5. So 3.5 is here, and here's 10 to 20, so from here to here. And that's it, guys. That's literally all you have to do. So I'm probably going to just fast forward this right now, yeah? So that's just the first example. I'll do one more, and then I'll fast forward this, yeah? So that'll be our first shape. Next one is, it's glitching a lot, isn't it? 20 to 35, height of 3. 20 to 35, 20 to 35. So 35 is here, and it goes up to 3. So 3, middle, down. Again, just like the what's it called, the straight line equation, where you have to plot a graph, you have to use a ruler. Yep, and this is the next one. So the rest is easy, I say. Okay, I'm just gonna literally fast forward this now, yeah. Okay, now let's move on to the next part. So B, work out an estimate for the number of these plants with a height greater than 40. Okay, so not too terrible. So let's look at the histograms where it's bigger than 40, right? So greater than 40 means the height mark is here. So we just care about the histogram. So let me just, I should move it slowly. So we just want something bigger than 40. So let's just shade in this part, yeah? So draw a straight line down from 40. And all you care about is the area from the rest of these blocks. So the area from here to here, well, let's have a look. This is 10 to 50, so the width is 10, and the height is 5. So 10 times 5, meaning this part of the block is 50. The next part, well, we know the frequency of this, and we know the frequency of those blocks. They're actually given. We know the last two is 40 and 8, so that means the area of this block is 40, and the area of this block is 8. So the total sum would be 50 plus 40 plus 8, which is 98. And that's how many plants that are greater than 40. 98 plants. Cool. Now 19. Without using a calculator, rationalize the denominator. Alright, this is easily one of my favorite questions. I'm not going to lie. This is really fun to do. So to rationalize the denominator, all you have to do is times up and down by the conjugate of this, so the inverse of that value. So instead of minus, it would be plus. So it would be up and down 3 plus root 7 over 3 plus root 7. The main idea is to pretty much get rid of the surds, because rationalize means no surds at the bottom. They just want strictly whole numbers. Okay? So what happens now? Because we've done this, we can just combine it, yeah? So we pretty much have on the top line 6 times the top half, so it'd be 6 times 3, which is 18. Now a whole number times the surd, you just stick together like algebra. So it'd be 6 root 7. On the bottom, we're gonna put into a double bracket form here. So it'd be 3 minus root 7 times 3 plus root 7. Okay, so I'm just gonna do it like that for convenience. Okay, now we're gonna try and solve it. So top is the same. 18 plus 6 root 7. God, that's an awful 18. So for the bottom, you just expand the bracket as you do, as a quadratic. So it'd be 3 times 3, which is 9. And then 3 times root 7, which is plus 3 root 7. And again, the same. I'm going to change colors to red. We're going to have minus root 7 times 3 is minus 3 root 7. And then minus root 7 times the positive root 7 gives you a negative whole 7, because 2 surds give you a whole. Plus, if you're not too sure, guys, literally just use a calculator. Just write root 7 times root 7, you get a 7. Now, tying this up, if you look at the middle two terms, you've got 3 root 7 and minus 3 root 7. These two cancel each other out, so these two become 0. Now, all you're left with in the bottom line is 9 take away 7, which is 2. So here we have 18 plus 6 root 7 divided by 2. This means you're going to divide the whole numbers above by 2. So 18 over 2 is 9. 6 root 7 over 2 is 3 root 7. Whole numbers of whole numbers, yeah? And that's it. This is your answer. Easy, I think. It wasn't too bad. Okay, next one. 20. Okay, so 20. So R and S are two similar solid shapes. Similar. So similar means they are in proportion, okay? So if R was a certain size, S would be proportionally bigger or smaller than that, okay? But still have the exact same sort of shape. Now, shape R has a surface area of 100 centimeters squared and a volume of 135. So R. So let's look at shape R, yeah? And shape S. We know that the surface area, let's call it A, is 108 centimeters squared and the volume is 135 centimeters squared. For shape S, the area is 300 centimeters squared and we don't know the volume. Work out the volume of shape S. Okay, easy way to do this, guys, is to use some sort of ratio formula, yeah? The trick is this. They say that the ratio between two shapes, so let's do shape S as the bigger shape, yeah? So it'll be shape S over shape R. The trick is like this. If you divide both these shapes using, in this case, a ratio, it's going to equal some common factor, some scale factor. I'm going to call this factor F, yeah? And depending on what it is, if you're dealing with area, it will be squared. If you're dealing with volume, it will be cubed. If it's linear, it will be power 1. So the trick of this question, guys, is to firstly find the scale factor between the areas. Yeah? So let's do that right now. So let's find the area of S, which is area S to area of R. So that's going to be 300 over the area of R, which is 108. And it's going to equal some scale factor squared because it's area. That means to find F, guys, all you're going to do is square root 300 over 1 over 8. Square root these values and you're going to get 5 over 3. That's easy to do. Just put a square root over 300 over 108. Now we know what the scale factor is 5/3. All you're going to do now is pretty much do the same thing but a volume. So we can say that the volume of S over the volume of shape R is now going to equal a scale factor cubed. Okay? The thing is, we don't know what S is, so the volume of S we don't know. But the volume of R we know is 135, and we know that the scale factor is 5/3, and that's going to be powered by 3. So all you want to do now is just times the right side by 135 to get the volume of S. So that means the final answer is going to be this, guys. It will be the volume of S would be 5 over 3 cubed times 135. And if you do that, you're going to get a volume of 625 centimeter cubed. And that's it, guys. 625. 625. Cool. And I think that question is done too. Now, 21. So looks to me like we're almost done, guys. Yeah, we've covered so far the first 20 questions. And if you've enjoyed this video, please give me a like, share with your friends, your schools, your teachers, your parents, your pretty much everyone. And I'll keep posting more videos whenever I can. I'm not gonna lie, it's probably a bit harder for me to post more videos than I used to, but I'm gonna start a proper plan and actually gonna start pumping out as many videos for you guys as possible. It also helps that if you guys want me to do certain papers, you can just email me if you got the papers of certain courses. And if I have time, I will do my best to publish it. Okay, especially if there's exams coming up. I'm going to also publish other kinds of videos in the meantime. And yeah, I'll show you what I'm going to do. I'll show you my plan and I'll keep you guys posted from now on. I'll try my best at least. But yeah, let's resume the paper. So, number 21. So, express, wow, all of this as a single fraction in the simplest form. Damn, that's a lot. Okay. Now, to do something like this, my advice is to always deal, if you've got times and minus and plus and divide, always start with the multiplication ones because they're actually easy to work with. I'm not going to lie, much easier to work with. We're going to come to the subtraction bit after, so this part we're going to leave it until the end, yeah? So for now, we're going to focus on these two groups. Okay, so factor. So to write this as a single fraction. To do this, guys, we need to firstly factorize as much as possible. let's go ahead. I'm going to copy the first fraction for a second, yeah? Another trick is to write them in bubbles. Always put these terms in bubbles. Okay, and it's going to be times the top half. Now, the 9x squared minus 4. There's actually a special formula here. It's called difference of two squares factorization, yeah? So dots. This means that if you got a square number on the first side and a square number second term, you can factorize them into two brackets, so like this. And the trick is like that. We say that the square root of 9x squared is 3x, so you write that on both sides. And the square root of 4 is 2, so it'll be plus 2 and minus 2. And that's it, guys. That's literally difference of two squares. You've got a difference between two square numbers, or square terms. Now for the bottom part, it's just a quadratic expression. It's a bit tricky, I'm not going to lie. You're going to have two big brackets again, because you've got an x squared term, an x and a number term. We know immediately that one of them is going to have a 3x and an x, because 3x times x is 3x squared. We also know that we need to find two numbers that multiply to make 10. So two pairs of numbers that multiply 10 could be as follows. We could have either 1 and 10. We could also have 2 times 5. So these are the only two pairs. Now the only difference between this one and the one we did previously is that there's now a coefficient of 3, meaning this is not just a regular x squared term, this is a 3x squared term. I mean, you've got to multiply one of these terms by 3 and somehow still get a sum or difference of 13. So there's quite a few things to consider. Now let's have an example, yeah? I'm going to pick the bottom set. If I multiplied, let's say, 2 by 3, yeah? Well, you got 6. 6 and 5. Can we get 13? No, not possible. If you multiply this 5 by 3, so let me just cancel this out. 5 times 3 is 15. 15 and 2, can you get 13? Yes. 15 take away 2 is 13. So this means you can multiply 3x by 5. And this has to be 2. Now the question is, can we get minus 10? Yes. One has to be plus, one has to be negative. So plus negative gives you a negative. Now to get minus 13, we need to do plus 2 minus 15. So it'd be plus 2 minus 5 times 3, which is 15. And that'll give us a negative 13. And yeah, guys, that's pretty much done. Now, because you got all of this done, the next step you want to do is literally cancel down. The good thing is, when you're multiplying fractions, guys, you can literally cross-simplify. So what that means, you pick something from the top and you cancel with the bottom. So let's do it right now. So I'm going to change the color of the pen. So looking up and down from our fraction, we've got 3x plus 2 and 3x plus 2, they go. We've got 3x minus 2 and 3x minus 2, they go. So now all you're left with, guys, is just 1 times the top, which is 1. And this is basically just 1 left. So nothing times x minus 5, or 1 times x minus 5 is x minus 5. Where'd I get 15 from? X minus 5. Okay, that's good. And now lastly, guys, that's pretty much the whole of the left side done. Now we can do the second part, which is minus 7 over x minus 1. So I'm going to write a fresh page here. So it'll be 1 over x minus 5, take away 7 over x minus 1. Now the good thing is, always wrap your denominators in brackets. Always wrap up your terms in brackets. And now we ask ourselves, how do we combine these fractions? Well, if you're adding or subtracting normal fractions, you always have to have common denominators. It's the same for algebra, guys. You need to have the same thing on both sides. So on the left side, we have an x minus 5. On the right side, we have x minus 1. So technically, the left side is missing an x minus 1 bubble, and the right side is missing an x minus 5 bubble. And to do that, you're going to multiply up and down by the same term, yeah? So if you multiply up and down by the same term, the left side is now going to get an x minus 1 at the bottom and an x minus 1 at the top. So that's what it is. So x minus 1 times 1, by the way, is x minus 1. On the right side, up and down gets x minus 5. And now they both have common denominators. So now you've got 7 times x minus 5 at the top and 1 times x minus 1. So now you've got common denominators, you can now combine the fractions. So we know the whole thing is out of x minus 1 and x minus 5. On the top line, you've got x minus 1. On the first one, subtract 7 times x minus 5. Now guys, all you got to do is expand the top, simplify, and you're pretty much, like, you're going to be done. That's a good thing, you're going to be done now. So let's do it. Expanding the top line, well, you got x minus 1, which is okay. You got minus 7 times x, which is minus 7x. Minus 7 times minus 5, which is plus 35. Over the bottom, I'm just going to do dots because you don't have to keep writing it. Oh yeah, another note, guys. When you're simplifying fractions, algebraic fractions, never ever expand the bottom half because it's not necessary. The purpose is that you're supposed to try and reduce as much as possible. If it's expanded, you can't reduce nothing. You always have to just keep in that form because it has no effect to the equation or no effect to what you can do next. So always leave it in this form, bracket form. Now going back to the top, so simplifying this problem, x take away 7x is minus 6x, minus 1 plus 34 is minus 34, and yeah, we're pretty much done, guys. I think you can just try factorize the top line. And yeah, oh, okay, not minus 34, guys, it's plus 34, yeah, because it's 35 take away 1. And yeah, so one last line. We can try and factorize the top line if possible. Well, looking at the top, we can see they both go into 2 times table. That's it, 2. I'm going to put 34 in front as well. So if I factorize 2 out, 34 becomes 17. Divide that by 2, you get 3x. So yep, this should be your final answer, guys. This is your single fraction. Single fraction doesn't necessarily mean single terms like one bubble, like x minus 1. It just means one whole fraction, and that's it. Now, 22. Okay, almost done, guys. It's almost done. Now, ABCD is a rhombus. So a rhombus, by the way, is just a parallelogram where every side is actually the same length. So if this side was 2, they'd all be 2, just for the sake of it, yeah? Okay. Now, the diagonals AC and BD intersect at point M. Okay, so AC and BD. So what I'm going to do, I'm just going to tie this up a bit. Erase this. Start giving some things some names now, yeah? So we're going to call this one A, B, C, D. It says the diagonals AC, so these are diagonals. So diagonals all the way across. And all the way across here. Intersect at point M. Okay. The corners of M is 6 minus 11. The points A and C both lie on the line of this equation, 2y plus 7x. So that's the line of AC. So line AC. My advice for these kind of questions, when you got lines, always put into y equals mx plus c form, where m is your gradient, yeah? So it's easier to see. Usually that kind of helps. And c is the y-intercept, yeah? So gradient, y-intercept. Okay, cool. Yeah, so what I'll do right now is make y the subject. So what we can do, subtract 7x and divide by 2. We can get y equal minus 3.5x and plus 10, because you're dividing it by 2. Okay, so that means the gradient of the AC line is negative 3.5. So it should be going downwards, not upwards. But who cares? Now, find the exact coordinates of the point where the line through B and D intersected the y-axis. Oof, that's an interesting one. Okay, when you got a rhombus, what that tells us now is that we're at right angles. Yeah, believe it or not, these are all right angles. Okay, so this is actually useful. So the reason why we found this line is because if you got a right angled line, that means we know that the line BD is perpendicular to AC. So BD is perpendicular, so it's perp to AD, meaning that the gradient is now reciprocated, is negatively reciprocated. So we know that the gradient of, so M, the gradient of AC was minus 3.5. Therefore, the gradient of the line BD is pretty much 1 over positive 3.5. And if you don't like the way that's written, 1 over 3.5 is actually 2 over 7. I should have just kept this as 7 over 2 in it, and this would be positive 2 over 7. Okay, so that's our line of BD is 2 over 7. Now, to find the exact coordinates, it's always useful if we know the equation of the line, yeah? So let's write this. So line of BD now. So line BD is always y equals mx plus c. We know that the gradient is 2 over 7, so y equals 2 over 7x plus c. Do we have the coordinates for this line? Yes, because m is part of that BD line. And we know m is 6 minus 11. So let's plug into that equation, yeah? So we can say at point M, which is 6 and minus 11, replace y with minus 11, and replace x with 6, and pretty much make c the subject, guys, yeah? So just solving this quickly. 2 over 7 times 6, 6 times 2 is 12, so it'll be 12 over 7 plus c. And then to find c, literally just subtract 12 over 7 across. So then c would be minus 11 take away 12 over 7. By the way, I don't have coronavirus, guys. I just feel a bit sick, yeah, if you're wondering. Because I know last time you guys are wondering if I had coronavirus. Nah, I'm okay. Alhamdulillah, I'm okay. So that's our C value. So we got our line equation, yeah? So our line of AB will be y equals, what is it again? 2 over 7 x minus 89 over 7. Whew, that's a mad one. Okay, okay, perfect. Now, let's go back to what the question 1 is here. So find the exact coordinates of the point where, when they say exact, don't round it up here. Keep it in fraction form. Of the point where the line through BD, so line BD, intersects the y-axis. Okay, so when something intersects the y-axis, just to know what happens here, if you intersect the y-axis, this means that we know one of the coordinates already. We know that the x-coordinate must be 0 because that's where it is. This is the 0 margin. So we know something is 0, but we don't know the y. Okay, and this is useful. What this tells us now is that we know when x is 0, we're going to literally be left with minus 89 over 7. So let's put it here. When x is 0, we basically have y equals 0, take away 89 over 7. So y equals minus 89 over 7. Oh my god, that's just the y-intercept, isn't it? So when something intersects the y-axis, that's the y-intercept. We have the y-intercept is minus 89 over 7. So that's another way. That's it, guys. So the coordinates would be 0 minus 89 over 7. Perfect. Perfect. Okay. Cool. Cool. And why is it so high up? It should be below. X-axis is here. Can't be above the x-axis. But yeah, that's cool. So let's move on to the next one. 23. Almost done, guys. This paper is actually, the last 5 questions are definitely more challenging than what we've seen before. I'll tell you that right now. So let's take our time. 23. Now curve C has equation y equals px cubed minus mx. So this is a cubic equation because you got x cubed. Cubic equation. Where p and m are positive integers. Find the range of values of x in terms of p and m for which the gradient of c is negative. Okay, so when you're dealing with gradient equations and when you've got something that's like cubic or quadratic, and then they're talking about gradient, they're simply telling you to use differentiation. So to find dy over dx, and dy dx is pretty much known as the gradient equation. Okay, so that's something useful. That's basically what they want you to do. And they're telling you now, find the range of values for x in terms of p and q for which the gradient is negative. So we just have to find it and say that, okay, dy dx is going to be less than 0. So we're going to do an inequality sign, because that means all value, whatever this is, it will be negative, less than 0. So now, let's just differentiate this equation. So we can say that dy over dx equals, well, to differentiate, all you got to do is drop the power of x down, so it'll be 3px, and subtract the power by 1, so it'll be 2. If there's no powers, the x vanishes, so you're just left with minus m. And I think we're pretty much done. So now all we do is say this is less than 0, and yeah, make x the subject. So we're going to be solving this part. So let's put m to the other side, add it across. So you've got 3px squared less than m, divide 3p across. You got m over 3p. The last step, guys, is the square root bit. And this is the part where you can drop or lose marks. Just think of this one for a second as equaling m over 3p, yeah? If you square root this one, you're going to get plus minus square root of m over 3p. Now, one thing to note, if it's less than, if the inequality is less than like we have now, the square root part will tell us that the values of x will be inside 2 intervals. So it will look like this. So this will be the form it will take. Positive root m over 3p and negative root m over 3p. However, if it was greater than, it's going to be kind of weird because the inequalities will just, they'll be separate inequalities. But for the sake of the argument, because it's less than, this is the form it takes. I'll show you. If it was greater than m over 3p, well, you'll get the same result, but then you'll get something like x will be way less than square root of m over 3p, and x would be way bigger than the square root of positive m over 3p, positive root m over 3p. So that would be if it was this case, but we're not doing that case, so that's not the result. But yeah, guys, this is it. This is it for question 23. Now let's see the final 2 sets. Oh, thank God, something that looks normal. Now 24. here are the first 5 terms of an arithmetic sequence. Okay, so we can see we've got an arithmetic sequence and it's going up in 7. Yeah, great. Work out the sum of all the terms from the 50th to the 100th term inclusive. Oof, man, I couldn't just say work out the first 100 terms like any other paper does. Okay, cool. Right. Okay, this is kind of, we've got to think about what we're adding exactly, yeah? What it's trying to tell us is that we're adding pretty much all the way to 100, but we're kind of ignoring the first 49 terms, I'm guessing, yeah? Because they want us to find the 50th term, the 51st term, all the way to the 100th term. So we're pretty much adding up every term it is, meaning we're ignoring the first 49 terms. So what you could say that the answer, let's call this the real sum. So the real sum is going to be, firstly, find all the 100 terms and then subtract the first 49 terms. That's what we're trying to work out here. Sum of 100 take away sum of 49. Now, to do this, we need to know a couple of things. We need to know our first term a, which is 8, is given. We know our common difference, which is 7. And yeah, and that's actually what we need. And the sum formula is actually given in the front of the booklet. Well, just to recap, the sum of the first n terms is n over 2, and then big bracket 2 times a plus n minus 1 times d. Okay, that's what it is. So we can say that for the sum of 49, that's going to be 49 over 2. So replace all the n's of 49. 2 times a is 16 plus n take away 1 is 48 times d. Okay, and thank God you can just use your calculator for this kind of work. So just put all in the calculator, guys, yeah? And you should get, just checking answers carefully, you should get 8,624. So that's the sum of the first 49 terms. Now likewise, so the sum of the first 100 terms will be 100 over 2, which would be just 50 actually. 2a again is 16, because 2 times a is 16, plus 100 take away 1 is 99 times 7. Okay, so almost similar, almost. So just basically repeating everything again, just using your calculator because you can. And this one you should get 35,450. And yeah, that part's done. Now you just subtract these two terms, guys, and you're pretty much done at this stage. So subtracting both of them, you should get a difference of 26826. So that's the sum of everything between them. I mean, I hope this is right. It says inclusive from the 50th to the 100th. That's what I understand. That's my interpretation of the question. I mean, if your interpretation could be 51st to 100th, I get it. Then you need to do the sum of 100 take away sum of 50. Either way, this would be the end of the paper. This would be almost at the end of the paper. So it's always good to try and do what you can. I mean, if you got the first 20 questions right, you're looking at grade 7 and above, or 8 even. If you want a grade 9, I'll say try and get as much as possible right, almost everything right if possible. But yeah, guys, let's hop on to the final question now, yeah? There's a lot of empty space here. It's jokes. Now, 25. I'm going to see how long this one is. Okay, oh my god, only 3 marks. Good, thank God. See, that's a generous final question. Maybe it's not easy, but we'll have a look. Now, the curve of equation y equals gx is transformed to the curve of equation y equals minus gx. Okay. So gx and minus gx. All that's happened, guys, is that all the y coordinates have flipped, become negative. So I think the best way to understand this is to think of a graph like that, yeah? If it was a, let's just say a U-shaped graph like that, and you got the axis here, wow, so much lag. This is now all the y coordinates have flipped. So this point here is now going to be reflected to this side. It's going to look like that. So every point gets flipped. So we can say that to describe the transformation of this shape, it's actually a reflection. Oh my god, this is lagging, it's horrible. Sorry guys, there's just so much writing, I haven't actually cleaned this up. So reflection across, what we call this line? Across the x-axis, isn't it? So it's always opposite. Even though the y coordinates are flipped, it's a reflection across the x-axis. The x-axis. I'm not gonna lie, I did this question previously and I wrote y-axis because I thought of that as y, and I did it actually the wrong way as well. So you're gonna probably see like a little edit in a second, which it was kind of weird, but the answer is x-axis, guys. Yeah, not y-axis. That's an important note. So let's move on to the final B and then wrap up. Okay, so this is a standard quadratic graph. Oh, thank God, they didn't even mix it up. Separate questions. Now, draw on the grid the graph of y equals 2 times a function when x is subtracted by 1. So, okay, so let's just go back for a second here. So this graph we have here is y equals fx. Let's do it in two phases here. Let's find fx minus 1 first, because that's the tricky one. Fx minus 1. What this means is that now, instead of subtracting with x values by 1, because that's the common like sense of we're looking at it, if it's inside a bracket, it's actually reversed. So instead of subtracting 1, you're adding 1 to every x value. So if this was originally 6 here, and now goes to 7. This is 2, and now goes to 3. This corner here is at, well, 4 minus 3. It shifts to the right to 5. Okay, so that's actually what they want. So changing the color of my pen, it will look like this. So it'll be kind of a smooth curve. This point goes here. This point goes here. It's kind of hard to always get it perfect, guys, but do what you can, yeah? So it'll be kind of like, yeah, oh man, that's actually decent. That's actually decent. Now, the next part will be 2 times that. So you're going to now multiply all your y coordinates by 2. So it stretches, yeah? So that means originally, this was at 3, right? This is now going to multiply by 2. So 3 times 2 stretches to 6. So it goes up to here. So I'm going to use another pen, actually. Let's use purple. So now it becomes here. Oh my, is that purple already? You know what? Let me just pick. I hate that color. That color is horrible. Okay, I'll use this one. I love it. It doesn't ruin the color. So that multiplies by 3. This corner multiplies by 3. Everything multiplies by 3 basically, except this one. This is at 0. 0 times 3 is 0. This bottom turning point 1 multiplies by 3. So minus 3 times, sorry, multiplies by 2, guys. Sorry, times it by 2. Times this by 2, it goes down to here. It stretches to here. So it's just like a really long one. Let me try and zoom out. Come on, zoom out, not draw. Yes. Okay, so you kind of have to just somehow make it work. All I know is that it's going to cross this point here. So this point, it's going to cross here. It's going to go, and this point here doubles, so it goes to here now. This one goes to here. So try and get some reference points in, guys, yeah? Oh, that is horrible. Okay, it can't be like that. Sorry. Drawing is hard. So that's, oh my god. But yeah, you guys get the point, yeah? So you just have to just get the points to connect. Yes. Alright, cool. Okay, and this one connects here. But yeah, it's going to be some kind of long U shape downwards, yeah? That's the graph you're looking at. And this curve should be more bent to the right a bit. And all the reference points, like literally just see any points that hits. Like, but unfortunately, there's none really, so yeah. But yeah, guys, that's pretty much the end of the question. And we've done it. That's the end of the paper. So I just want to say, guys, thank you so much for coming to watch all this paper with me. You know, I appreciate your support as always. And thank you guys for, you know, years of contribution. I know some of you guys have been here for a while, for even multiple years. Not just to watch these math videos, but you've also watched like later ones, more advanced videos. And yeah, just, I don't know what I can say. Thank you for your support. One day I hope to visit you guys in your countries, because you guys invited me to see you guys. I'm like, sure, no problem. I'll meet your families, and yeah, bring my wife. We can have some tea, can relax. Yeah, it doesn't just have to be about maths, guys. Yeah, there's loads of things we can talk about. But yeah, thank you again for your support, and I appreciate it all. And if you guys enjoy this video, please give me a like and subscribe, share with your friends, and get ready for the second one. Okay, because there's also always gonna be a paper 2 of this one. So yeah, ciao guys, salam alaikum, and have a blessed day, and enjoy the rest of your revision. Take care, bye.